How many people are infected of coronavirus right now in this moment in Italy? I think this can be calculated, and I think that it's really important that we do this, not just for Italy, but for a lot of other nations, because the same calculation can be applied everywhere, although sometimes the constant might be a little bit different. So to calculate this, what we need is the daily growth of the virus, the fatality rate, the average number of days between infection and death, and the number of deaths. Now the fatality is basically the number of dead divided by the number of infected people. And this is actually quite hard to calculate. I made a video for now only in Italian about various ways to calculate it. For now, we just take the evaluation from the World Health Organization, in Italian is OMS, which is about 3%. And so let's start with 3% over there. And then the virus tend to grow exponentially at the beginning. And the number of infected people, the number that is declared by the state of infected people is not and cannot be the real number of infected people, simply because the state cannot test everybody. And in fact, recently they started testing as little as possible. They only test people before they put them in intensive care unit or in the hospital. Basically, a lot of people are untested. But assuming the fatality rate is constant, then the number of dead people grows with the same exponents as the number of infected people. And then we can use the number of dead people to extrapolate the growth speed. There is here the number of infected people in Italy because of coronavirus. And you can see that is a graph that goes up. But more interestingly, if we plot it in on a logarithmic chart, log normal, it actually is a straight line, which basically means that it is an exponential growth. And in fact, we can actually we can actually try to predict where this is going by making a model. And if we start with 7 people dead on the 24th of February, and yes, we are discounting the first number. It's common in exponential growth that the first numbers are quite imprecise. So, and then we increase by 35% each day. You can see how closely it is actually tracking it. And this is how it goes up and how it looks like that is growing. So now we can say that the growth of the virus is about 35%. Now, what about the number of days between infection and death? And here we can use the literature and doctors will actually tell us that it takes about 20 days for a person who catches coronavirus, if he's going to die, on average to die. The first days are usually asymptomatic, then they have mild symptoms, then it gets worse, and then the situation worsens. Eventually, they might die around 20 days later. And here we are only considering people that actually die. So we can put 20 over here, and we leave the number of deaths for the side. And so if you find a person that just died, what can you tell about what is the situation around you in that moment? And what can you tell is that probably on average there were 1 over f. If the fatality rate is f, you have 1 over f people that were infected n days ago. Let's try to understand this better. The fatality is 3%. So this actually means 3%, you can write it as 0.03. And this actually means that for every 1 person that dies, for every 33 persons that are infected, 1 usually dies on average. And so when you find a dead body, you can say, well, 20 days ago, there were 33 persons infected, but 20 days ago, what happened in those 20 days? Well, it happened that those people infected other people, which infected other people, and so on. So the whole thing grows, and grows at a certain speed, about g% each day. So after one day, we have n0, so the number of infected people on the first day, actually on the 0 day, plus the same number multiplied by the growth. And so if you have 100 people infected after one day and the growth is 10%, after one day you will have 100 plus 100 multiplied by 0.1, because 10% you can write it as 0.1, and that's equal to 110. And then if after one day you have n0 plus n0 multiplied by g, which is the growth, you can actually write this as n0 multiplied by 1 plus g. There's a little bit of mathematics, but don't worry, this is pretty much all the mathematics you are going to see. Okay, there is one other formula, but it's still simple. And after 2 days is n1 multiplied by 1 plus g, which is, and then if we substitute to n1 and 0 multiplied by 1 plus g, you actually get n0 multiplied by 1 plus g multiplied by 1 plus g, which is n0 multiplied by 1 plus g squared. And then it's extremely easy then. Then you can say that after 2 days, you need to multiply by 1 plus g squared. After 3 days, you need to multiply by 1 plus g at the cube, and after m days you need to multiply by 1 plus g at the exponent m. So let us imagine that we have 33 people that were infected 20 days ago. Now after 20 days, what will happen? It will happen that those 33 people, we need to multiply then by 1 plus 0.35 elevated to 20, which is 1.35 elevated to 20, which is 404. But when we multiply this, we obtain 13,462 people that are infected. So for every person that dies, we can assume that there are around 13,462 people. This with an average growth of the virus of about 35% a day. But right now, in Italy, there are 631 people that are dead by the virus. So we probably should assume that we have 8,500,000 people, that is 14% of the population, that is infected by the coronavirus, at least following this growth. This sounds like a lot. And then, of course, one would say, okay, how long will it take to actually infect everybody? And it would actually take not that long, because with exponential growth, the real action happens in the last part. So you have a very slow effect, and then boom, explodes and takes and covers everybody. So, but of course, an exponential growth cannot go on forever, and this is due to the fact that, in 1 week we would have everybody infected in Italy. So, and this is, all the doctors tell us that this is impossible, that there are some people who are not going to get infected, and so on. So we are soon going to get out of the exponential growth. But even when we get out of the exponential growth, we will not actually see it from our data, because our data is not the number of infected people, but it's the number of dead people. We used the number of dead people to calculate the number of infected people. So in any moment we get from the number of dead people, we go up and we see the number of infected people. But there is a point in which people are not going to keep on getting infected, but the number of dead people will keep on growing. and this is inevitable because it takes 20 days for people to die. Now let's recapitulate everything. If you want to know how many people are infected, assuming that the development is exponential, if you have the growth, if you have the fatality rate, if you have the number of days between being infected and dying, then you can apply this formula, which is n, number of dead people, multiplied by 1 over f, multiplied by 1 plus g elevated to d. You could actually write this in a more elegant way like this, but it's not really easier. What instead would be easier is to notice that 1 over f multiplied by 1 plus g elevated to d is a constant, because f is the fatality rate and that's a constant, the growth is a constant, and the d is also a constant. So this k, we can actually just calculate it, and we calculated it before. If you remember, this k was exactly 13,462. So at that point, the number of infected is just n multiplied by this k, and this k is not the same for every country. So please be safe, please stay home. I will make other models in future, and also if you would like me to analyze your country, I can, and just let me know in the comments. Thank you very much.